And today we are going to start the topic probability. We have studied the probability in 10th and in 12th, so we'll continue the properties of and the laws of the probability, right? So here we are going to discuss few laws. So we say that if A and B are events associated with random experiment, that means A and B are just random experiment and they are associated, and so that the sample space of the events is S, right? So in the first law it says that if A is a subset of B, then the probability of A will be either equals to probability of B or it will be less than B, right? And the probability of B minus A will be equals to probability of B minus probability of A. Alright, and the second point is given that if A and B are mutually exclusive events. What are mutually exclusive events? Those events which do not have anything common. That means the intersection of A and B is 0. The probability of A intersection B is 0. Then we say that probability of A union B, it will be equals to probability of A plus probability of B. Alright, and the third point is given that if A and B are mutually exclusive and exhaustive events, then we say that probability of A union B is equals to the probability of sample space, and the probability of sample space is 1. So now we can say that the probability of A union B or probability of A plus probability of B, it will be equals to 1. Alright children, please note down. Let's see few more laws, children. Again, if A, B are events associated with random experiment having sample space X, then probability of A union B will be probability of A plus probability of B minus probability of A intersection B. This we have studied in set theory class 11. Probability of A minus B will be equals to probability of A intersection probability B complement, right? Either we write A minus B, cardinal number of A minus B is equal to cardinal number of A intersection B complement. So here the probability will be same. We have studied cardinal number in set theory. Probability of B minus A will be equals to probability of A complement intersection B. Alright. Now probability of A plus probability of B can also be represented as probability of A minus B plus probability of B minus A plus 2 times of probability of A intersection B. And if A, B and C are 3 events associated with a random experiment having sample space X, then probability of A union B union C, it will be equals to probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of A intersection C plus probability of A intersection B intersection C. Alright children, please note down this much first. Let's see this sum, children. Here it is given that probability of A 3 by 5, probability of B 1 by 5. Find probability of A or B given that A and B are mutually exclusive events. Now A and B do not have anything common. That means the intersection of A, probability of A intersection B will be 0. So now we have to calculate the probability of A or B. That means we have to calculate the probability of A union B. Or means union and means, suppose it is written find the probability of A and B, that means they are saying that find value of probability of A intersection B. Alright children, don't get confused in and or. So we have to calculate here value of probability of A union B. Now the probability of A union B will be, when A and B are mutually exclusive events, we have studied in the law of probability that it will be equals to probability of A plus probability of B. Now substituting the value of probability of A as 3 by 5 and probability of B as 1 by 5, when we add we'll get 4 by 5. Please note down. Now let's see this sum, children. In this sum it is given that if E and F are even such that probability of E is 1 by 4, probability of F is equals to 1 by 2 and probability of E and F equals to 1 by 8. Find probability of E or F, and first part, second part, find probability of not E and not F. Okay. Let's see this one, first part, probability of E or F. E means or means union. That means we have to calculate the probability of E union. So the probability of E union F, it will be probability of E plus probability of F minus probability of E intersection F. Alright. When we substitute the value of probability of E as 1 by 4, probability of F as 1 by 2 and probability of E intersection F, which is given probability of E and F, it is 1 by 8. When we substitute the value and take the LCM, we'll get 5 by 8, which is the first answer, probability of E or F or probability of E union F. Alright. Let's see second part. It is here. It is given that find the probability of not E and not F. That means we have to calculate the probability of E complement intersection F complement. So this expression E complement intersection F complement can be written as probability of E union F to the whole complement. So when probability of E union F complement you have to calculate, then it can be written as 1 minus probability of E union F. Alright, and this value we have already calculated, which is 5 by 8. So when you substitute probability of E union F as 5 by 8, 1 minus 5 by 8, it will be 3 by 8. Alright children, please note down. Children, let's see another sum. Now in this sum it is given that a card is drawn from a well shuffled pack of 52 cards. What is the probability that it is either a spade or an ace or both? So let's say event A is happening a probability of spade card. So how many spade cards we have in one pack? It is 13 spade cards. So probability of happening A will be 13 upon 52 or 1 by 4. Let's probability event B is happening is an ace. Probability of happening is space. So probability of happening of event B will be 4 upon 52, right? And probability of happening both A and B, so it will be, we have only one card which is ace and spade both, so we have only one ace ace of spades in a pack, so the probability of happening A and B together, it will be 1 upon 52. We know that the probability of A union B is probability of A plus probability of B minus probability of A intersection B. So when we substitute the value, we'll get 13 upon 52 plus 4 upon 52 minus 1 upon 52. And when we take the LCM and solve, we'll get the answer 4 upon 13. So 4 upon 13 is the probability of getting a card which is either spade or ace or both. Alright, please note down the solution. Let's see another sum, children. Now in this sum it is given that if two dice are thrown simultaneously, find the probability of getting a sum of 7 or 11. Now let's say event A is happening, getting a sum of 7, and event B is getting a sum of 11. So how many events that's in favor of event A? Either 1 comma 6 can come, 6 comma 1 can come, 2 comma 5, 5 comma 2 will also sum as 7, right? 3 comma 4 or 4 comma 3. So how many events are there? There are 6 number of events in which is in favor of event A, and in let's B is the probability, or the event B is the sum of 11 we are getting, right? So 11 can be, we can get by adding, either in first die we'll get 5 or second die we'll get 6. First die will get 6, second die will get 5. All right. So there are only two ways to obtain 11 in a throw of 2 dice. Right, and the sample space when we throw 2 dice simultaneously, it will be 36. Right, so probability of happening A, and there is nothing common in between A and B, so we can say that A and B are mutually exclusive events. So probability of happening A is 6 by 36, probability of happening B is 2 by 36. So the probability of happening either A or B, it will be probability of A plus probability of B. So that will be 6 upon 36 plus 2 upon 36, 8 upon 36, which is 2 by 9. Alright, please note down. Now let's see another sum, children. Now here it is given that 2 cards drawn random from a pack of 52 cards. What is the probability that the cards are either both aces or both black cards? So let getting both aces be event A and both black cards be event B. So we are drawing 2 cards from a pack of 52 cards, and how many aces we have? We have 4 aces in one pack. So what is the how many favorable events that we are getting? Both the aces. When we are drawing 2 cards, it will be 4C2, and any 2 cards that we can obtain, that means the sample space on drawing 2 cards will be 52C2. Both the cards are black cards. How many black cards we have in a pack? 26. So we are drawing 2 cards from 26 cards. So what will be the number of favorable events? It will be 26C2. Total sample space 52C2. So the probability of getting B will be 26C2 upon 52C2. And probability of getting either A or B, that means either both the cards be aces or both cards be black, and both the cards be black, that means A intersection B we have to find. Now how many aces and black cards we have in a one pack? We have only 2 cards. Okay, aces of spade and aces of club, both are black cards and both are ace as well. So there are 2 cards and we have to draw 2 cards from those 2 cards. That means the probability favorable events will be 2C2 and sample space is 52C2. So we know this formula, theorem, law, that probability of A union B is probability of A plus probability of B minus probability of A intersection B. So when we substitute the values 4C2 upon 52C2 plus 26C2 upon 52C2 minus 2C2 upon 52C2. So when we substitute the values after simplifying and take the LCM, We get the value 330 upon 1326. We cancel out by 6. We'll get 55 upon 221. That will be the answer. Alright children, please note down.